Hydraulic systems give us a very nice example of how pressure works. Picking up a car is a hard thing to do, even for machines. Let's imagine there's this car that's, say, 1,500 kilograms. We use what's called a hydraulic system to lift the car more easily. Now, that's basically two circles connected by a liquid. So the car sits on a platform over here with a large surface area A, and there's a small surface area here. And we apply a downwards force on that little platform. So F1 will be pointing down, and little surface area A is smaller. So if we think about the pressure formula, what we get is this. So pressure is force divided by area. So because the area is smaller, what's going to happen is the pressure here coming down is going to be larger. And the fluid will transfer this pressure all the way over here, up there. So the pressure here is going to be the same as the pressure there. And for that side, we're going to say there's a larger area. So that means with an equal pressure, the force will be larger. So with this little trick of using different area size circles that we're pressing down on, we can take a smaller force and multiply it through kind of leverage into a larger force. A key idea inside here is that the fluid takes the pressure from here to over there. And this has a big fancy name, which is incompressibility. And it's important to understand this when we're thinking about a fluid. A fluid is something that doesn't hold its shape normally. A solid holds its shape, but a fluid moves around like that. The idea of incompressibility is about containing fluids. So if we have a container of fluid and we press down on it, to be incompressible means I can't really press down on it at all. Imagine there's this little box here and there's some fluid between two pistons that are trying to squeeze it. So if I squeeze it, I'm trying to compress, make smaller the fluid. And if it's incompressible, what we're saying is that we can't make the volume of this area any smaller. So if I push on that side, it's going to push that way. If I push on this side, it's going to push this way. If I had a sponge in the middle and I press this way, maybe the sponge will compress or squeeze. The best way to improve your grades is with a practice test. On my website is a free fluids practice test. If you do it and submit it to us, we'll mark it for you totally free. Let's just do an example with numbers. Let's imagine two platforms that are just circles, and we'll say one has a radius of 3 meters and the other has a radius of 0.5 meters. And we place a car onto the big one of, say, 1,500 kilograms. How much force will we need to press down here to lift the car? We can begin by calculating the force of gravity on the car, mg. That's going to be 15,000 newtons. And now we've got to think about pressure. So how much pressure is occurring over here? Pressure is force divided by area, so that force divided by the area. So we get 530 pascals. And now we say the pressure that's going to be here is going to be equal to the pressure down there because the fluid is incompressible. If I press down with that pressure, it'll create that pressure over there. So I just need to put in the numbers for the pressure and the area, which is going to be this area here. So I get that the force that I need to apply downwards on here is 416 newtons. If we think about the force of gravity of the car, which was 15,000, that is much, much less. So we have a very different area, and so we need a much smaller force to be able to press down on that. If we think about proportionality for a second, that'll help us consider the same question another way. So what we're saying is that the pressure needs to be the same at the two sides. So we can say F1 divided by A1 is going to be equal to F2 divided by A2. If I put force on one side, area on the other side, I get this. Basically, this is saying the step up in area is going to equal the step up in the force. So I could calculate the ratio of the forces by calculating the ratio of the areas. So it's going to be like 1 over 6 squared. So the ratio between the area of the little circle, and the big circle, that ratio is 1 over 36, saying that the big circle is 36 times larger than the small circle. That means the force here can be 36 times smaller than the force required there. Have you ever seen a hydraulic system working in practice? Comment below if you've ever seen that.